Hey guys, in this video I'm going to review this 48 volts battery, 100 amp hour capacity from Energy Future Green, and this is going to be most detailed and in-depth testing for this type of battery. In this video I'm going to test capacity for this battery at 0.2 C rating, at 1 C rating. I will test high voltage disconnect, low and high temperature disconnect. I will try to connect this battery via CAN bus to solar converter. We will see if it's going to communicate. And of course, I'm going to disassemble this battery to see how well it's built inside. And right now I'm going to do capacity test. Before that, I did cycle this battery 5 times. And if we check on the BMS, right now we have voltage 54.29 volts. So I'm going to enable inverter to charge the battery with 20 amps, and the charging voltage is 57.6 volts per specification for this pack, which is going to be 3.6 volts per cell. We're charging with 22 amps and voltage is 55.1 volts. So I guess cell number 16 will first reach 3.7 volts, which is disconnect voltage in the BMS for this pack. Reaching 3.7 volts and 55.9 voltage on this pack, and maybe you hear this click, relay disconnected battery from inverter. And now I'm going to reset this meter and we'll do capacity test. Right here I'm running test where we draw 20 amps and for 6 minutes right now. And let's come back in 5 hours and we will see results. And the test just finished. It took 4 hours 58 minutes. We've got 101 amp hour capacity, 5 kilowatts, 240 watt hours. And let's see voltage difference. The specification for this battery is pretty standard. It's 51.2 volts, 100 amp hours. On the side right here we can see operating temperature and charge and discharge recommended current in 0.2 C, which is 20 amps, and the maximum charging and discharge current is 100 amps. On the front cover of this battery we have LEDs to check what is the state of charge, if we do have any alarms and if battery is working. And then we have the screen where we can see more detailed information. If we press on the screen we see this welcome menu, and then we can read some information. In analog info we can see what is the pack voltage, what is the percentage going in or out from a battery. Then on the temperature we can see information from 4 temperature sensors located on the cells and 2 additional sensors located on a BMS. Then we can see individual cell voltage for all 16 cells, and in the cell capacity we can see what is the state of charge, what is the amp hours for our battery, what is the remaining, and how many cycles we did. Then on the BMS status we can see that it's charging right now. Then on the record we can see if any protection happened: short current protection, over and under temperature protection, over current protection, under voltage, and over voltage. Then on the BMS status we can see if any of these events happening right now. Then parameter settings, and the system settings is just the communication speed for this battery. And that's all information we can read from this screen. And here's the battery fully disassembled. We have 16 cells. Each cell is 100 amp hour or 320 watt hours. Right here we can see some serial number or maybe part number. And each cell on the one side has this soft material to prevent cells rubbing from each other and moving inside a box. Then right here is a battery management system and the communication board. On the bottom right there I can see many MOSFETs. And then for disconnect we have 2 options to disconnect this battery. First is a button on the box right here, this power button, and then we have these circuit breakers. This is 125 amp hour circuit breaker, and what is interesting, this circuit breaker is rated for alternating current, so it's not rated for DC power. I even purchased another circuit breaker on eBay. It's exactly the same breaker, and I did my own test with 125 plus amps to see how it's gonna work with disconnect. I was expecting it's gonna burn, but you can see results later in this video for testing this circuit breaker. Then if we look inside right here in the box, for battery compartment, it all has this soft material, so cells were nicely secured in this box. It's separated from electronic parts. And then for terminals and for temperature sensors, we had those two metal plates, and then we have 4 temperature sensors installed on the cells. 1, 2, and then this is number 3 and number 4. And that's it about internal components for this battery. The battery was just fully recharged. We're at 100% SOC. I did reset meter, and I'm going to apply 1C rating 5 kilowatt for this battery, and we will see how this is going to handle this load. Let's come back in about 30-40 minutes and we will see what is the temperature for wires and cells. If we look at this box, it's made from pretty thick metal, and the weight for this box from this car about 9 to 10 kilos. On the back of this box, right here is 2 large brackets which are supposed to go in contact with this plate, and this plate connects into the wall, and then pretty nice and secure connections of the 2 of them. On the front cover, this could be separately removed by unscrewing all of these bolts on the perimeter, and then on the back side we have just a screen with the buttons and LED to see what is the quick status of the battery. Now I'm going to test communication between battery BMS and the SolarEng inverter. I did connect this Ethernet cable to SolarEng battery CAN bus, and I did connect this to CAN bus right here. And then in the SolarEng we have to go to battery setup, enable BMS lithium battery, and after that we have lithium battery information, so we can read information from the battery. At the first attempt it didn't work, so I went to documentation and I found that on a battery for CAN bus it's using pin number 4 and 5 for communication and pin number 7 for ground. But in the SolarEng documentation I found that for CAN bus it's using 4 and 5 pins also for communication, and pin number 2 is a ground. So I have to cut this cable and redo connections, and after doing that it did work. And just quickly explain why we need this communication. If, for example, we're charging our battery and one of the cells reaching high voltage, without communication, what's going to happen? BMS will cut power from charger or inverter, and potentially it could damage equipment. When we do have communication, BMS, before cutting power, it will send signal to inverter and will let this know that we need to stop charging battery. So instead of cutting power, it will tell other source, inverter or charger, to stop doing that. And now right here is a test setup. What I did, I disconnected cell number 3 sensing lead right here, so it's not connected to the cell anymore. and connected this to power supply. So we can simulate high voltage disconnect. And right now we're charging battery with 1.3 kilowatts. And what I'm going to do, just to increase voltage on cell number 3, and we will see if it's gonna cut the power. So I'm gonna do about 3.6 volts. Now let's see on the inverter side. Now I can see this exclamation mark, and in theory it should start reducing charging power. Yeah, and it's happening right now. So it was charging with 1.3 kilowatts, and now it's dropping charging. And it just stopped charging. So here's a confirmation that this battery could communicate with the inverter. In a package with the battery, we're getting user manual, inspection report for lug bolts, anchor bolts, this mounting bracket, and batteries. Here's my final thoughts after testing this battery. On the positive side, I do like to see multiple form factors. You have choice how to mount this battery on a wall vertically or horizontally, or using server rack mount. Second positive item is a full capacity at 1 C rating. I did test many lithium iron phosphate or lithium ion batteries, and it's first time when I do see full capacity at 1 C ratings. And number 3 is the communication. It's great to see that this battery could communicate with multiple inverters, and this communication will add a lot of stability to solar system. Instead of relying to BMS to connect and disconnect charge or discharge, having this communication is a huge plus. Alright guys, that's all about this video. I hope you did like this review. Thank you for watching, and see you in the next video.